Good morning, welcome to
MathForKids number 144.
MathForKids number 144. Today we're going to talk about exterior, interior, and exterior angles in polygons. Okay, so we're going to start with this simple one, and we're not going to explain why this is true. But maybe someday we'll make a video about this. Maybe we already have. The angles in a triangle, if I call them A, B, and C. Angle A plus angle B plus angle C, a triangle adds up to what?
180.
180. Actually, I will explain it, why this is true. Do you remember why this is true? Remember how you show this?
The interior angles add up to 180?
Yeah. What else adds up to 180? Angles in what?
Angles on a straight line.
Angles in a straight line. So what you do is you pretend there's a straight line here that's along the base of the triangle, and you make a parallel line up here. Okay, then by the parallel line rule, this angle has to equal what? You know which angle is the same as this one? Right, this is angle C, because this line here comes down and intersects this line with this angle, that line with that angle. So this angle and this angle are the same. And this angle here has to equal what angle?
B.
B. Okay. So this is just a quick review of why angles in a triangle add up to 180, because when we draw these two extra lines in, we get angle A, B, and C end up being in a straight line up there. So the angles in a triangle add up to 180 degrees. Now we can say, if we have four sides, remember what a figure with four sides is called?
Quadrilateral.
Quadrilateral. Whoops, not the best quadrilateral anyone's ever drawn, but we're going to have A, B, C, and D here. And how do we figure out what these angles add up to? Do you remember what you do?
You chop it in half. You can chop it up into triangles.
You chop it up into triangles, and here's a green pen for you. Oh, sorry, I didn't realize you already had a pen. But here, draw it in green because it's a new line. What line do you want to draw here?
You can chop it like this.
Okay, you chop it like this into this triangle and this triangle. And we notice that the angles of this triangle plus the angles of this triangle add up to be the same angles of the original quadrilateral, because we have this angle, we have this angle plus this angle, we have this angle, and we have this angle plus this angle. Okay? So, and we can do this for any quadrilateral, right?
Yep.
So angles in a quadrilateral, I'm just going to write Q, add up to what?
360.
360 degrees. Okay, that's pretty neat. Okay, now, what about if I have a figure that has lots of sides? Okay, so we have an angle here, 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 and here. Okay, what are you going to do? What do you think you do? If we're going to try to figure out what these angles add up to.
You can do the same thing you did for the triangle. But you have to try. You could the same thing for the quadrilateral.
Right. You do the same thing you did for the quadrilateral. You try to chop it up into triangles. So here, draw a triangle there. Okay, draw a triangle here. And then draw. Can you reach it, or do you want me to draw it? No, here, from here to there.
Or you could go down like that.
No, let's do them all from the same point. Okay. So how many sides did this figure have? Count them.
1, 2, 3, 4, 5, 6.
And how many triangles did we get?
4 triangles.
Now, is that an accident that it had 6 sides and we got 4 triangles, or is that always going to happen?
It's always going to be true because...
Okay, what's always going to be true? The number of triangles is
is always 2 less than the number of sides.
Why is that? You see it? Can you see it from this picture? That the number of triangles is always going to be 2 less than the number of sides?
Because each triangle has 2 angles, has 1 and 2 halves of the angles.
Okay, not quite. We have 6 sides, right?
Yeah.
And I have 3 lines that come out from one of my sides to chop it into 4 triangles. So let's see what happens to the number of sides. I guess, you know what we're going to do? We're only going to talk about the interior angles today. Tomorrow we'll talk about the exterior angles because I want to make sure you understand this. So here's a 6-sided figure. We started drawing triangles from one vertex, and we drew 1, 2, 3. The 3 lines chopped up into how many triangles?
Into 4 triangles.
Into 4 triangles. Okay. So we have to figure out for a general figure that we draw, if we start at one point, how many lines are we going to be able to draw? Well, notice we start out at one point. So we have 6 vertexes. Is that going to be too complicated?
No.
Let me instead of using complicated math words, let me just say we have 6 points. 1, 2, 3, 4, 5, 6. Now, how many lines are we going to draw? Well, do we draw a line from the point to itself?
No.
So x, 1 point. Okay, so we don't draw a line to there because that wouldn't make a triangle.
You can't draw a line to this one.
X the point on one side. Okay, so does that make a triangle?
No, it's a line.
It's a line. Okay, so we got to get rid of that point. So that we won't draw to that point. Are there any other points we won't draw to? That one. X point on the other side. Okay, so we're going to draw, but we draw a line to all the other points, right?
Yeah.
So how many? If we have 6 points, how many lines do we draw?
We draw 3.
Okay, if we have 10 points, how many lines are we going to draw?
10 points. You still have to X out 3 of them, so it's going to be 7.
Right. If we have 100 points, how many lines are we going to draw?
97.
97. So you're drawing to all of the points except the one you're starting at and the one on either side, right?
Yeah.
Yeah. Okay. Now, when I draw 3 lines, how many triangles do I get?
You get 4 triangles.
Okay. And in my 10-sided figure, when I draw 7 lines, how many triangles do I get?
You're going to get 8.
Why? Why do I get 1 extra triangle?
Because you make 2 triangles with the last cut.
That's exactly right. High five. Each line makes a triangle. Good observation. Give me, where did I do that green pen? Each line makes 1 triangle, except for the last line. 1 triangle. 1 triangle. Oh, the last line makes 2 triangles. Okay? So, when I have, let's write this in general now. I have n points. Which gives me n minus 3 lines. Which gives me how many triangles?
It's n minus 3, n minus 2 triangles.
Okay, so here I had 6 points, 3 lines, and 4 triangles. Okay?
Yep.
So that means the angles add up to... Well, how many triangles do I have?
You got
How many triangles?
n minus 2.
And how many angles? What do the angles in a triangle add up to?
180.
I have a feeling that we did this whole video video, and we're not on the screen there for that last bit. Oh, only the very last bit wasn't on there. I got lucky, so we can actually save this video. It's right there, n minus 2 times 180. Let me see if that's on. Okay, so n minus 2 times 180. So the interior angles of a polygon add up to n minus 2 times 180. So if I have a what? 7-sided polygon, what are the angles going to add up to?
5 times 180.
Right. And what is 5 times 180?
900.
900. Good job. Good job, sweetie pie.